I'm going to make a transformer now. So here I've got a power pack supplying alternating current to this coil. The coil will have a magnetic field when current flows through it, and the soft iron core will take on the magnetic field. Here I've got another soft iron core that's going to connect onto it. The magnetic field will flow through all of the iron. Now, because the magnetic field is alternating, it will induce a current in this coil here, which will hopefully light up the bulb. First, let's have a look at what happens when I turn the power on. We see no lighting up in the bulb. When I connect the two iron cores, we should see they've attached together magnetically and the bulb is lighting up. Now this is the primary coil. The number of turns on the primary coil is 16. The number of turns on my secondary coil is 25. Let's see what the voltages across each coil are. Here's my voltmeter. Across the primary coil we have 1.8 volts. Across the secondary coil, 3.0 volts. Let's use our equation to see if let's test our equation for transformers, which is that the voltage across the primary coil divided by the voltage across the secondary coil should equal the number of coils on the primary coil divided by the number of coils on the secondary coil. So let's plug in our numbers. 1.7 volts over 3.0 volts should be equal to 16 coils over 25 coils. Well, 1.7 over 3.0 is 0.57. And 16 over 25 is 0.64. So it's not perfect, but we're close. Let's have a go with one more coil. Here is an even bigger coil. Now this coil has 40 turns. I'm going to call this just Ni. Let's see how this affects the voltage. So I'm going to turn on my transformer again, connect them up, and we can see the light came on when I connected it up. I'm going to bring my voltmeter in. The voltage across my primary coil is now 1.8, and the voltage across my secondary coil is now 4.9. Let's turn it off. So Vp equals 1.8 volts. Vi, remember I'm referring to this one as I, was, 4.8 volts. Let's work out the maths for this one. We should have Vp over Vi is equal to Np over Ni. So we get 1.8 volts over 4.8 volts is equal to 16 over 40. Well, 16 over 40 is easy. That's 0.4. Let's use the calculator for this one. 1.8 divided by 4.8 is equal to 0.375. So we're very close. We're actually slightly the opposite way. Maybe I didn't count my coils perfectly. But there we've seen not only that we can transfer energy using a transformer, but we've also checked the calculations for a transformer.